We'll see if the volume works. If not, this might be a video that doesn't work. It says that it's working, but I keep getting error messages. So we'll find out. It says determine the non-permissible values. So we have to find out where it's undefined. Just like on our quiz, you had questions to say where things are defined and undefined. In mathematics, you're not allowed to divide by 0, and you're not allowed to square root a negative number. In these questions, we just have fractions. So the only thing you're going to have to check for non-permissible values is, are there any places where you might divide by 0? And then it says to prove. We're actually going to start with the prove part because the second, non-permissible values is actually easier once you've done the proof. So again, format for proof. You rewrite the question and draw a line separating the left side and the right side. We've learned some strategies so far. One of the strategies that we learned was if we can change things to either sine or to cosine, usually that makes it better. And if we do that and we get a single fraction on both sides, maybe things will work out. So on the right-hand side, I already have cos. But if I look at the left-hand side, I could change cotangent, and it makes more sense to change cotangent to sine and cos than it would be to change it to 1 over tan. All divided by and cosecant, I can change to 1 over sine. So I use my toolbox, the things that I already know, I change everything to sine and cos. So it's very important that you have all of your known identities, your definitions memorized, because you're going to need to use them often and quickly in a proof. So knowing that cotangent is cos over sine and cosecant is 1 over sine. Now I have a fraction divided by a fraction, so that's the same as multiplying by the reciprocal. So I take that bottom fraction and I flip it. And now I notice that I have two factors that are identical. They will simplify because we're multiplying. And I get cos theta, so my left side is equal to my right side. And we're done our proof. Now we can go and look. What are our non-permissible values? What's not allowed? I'm going to take out my highlighter, and after I change to sine and cos, I'm going to check everywhere that I'm dividing. And after checking everywhere where I'm dividing, what do I notice is on the bottom? Sine of theta. So our non-permissible values is solving the following. We know that sine of theta can't equal 0, because if it does, we would divide by 0. And then we have to think about, well, when does this happen? On our pie plate, is the y value ever 0? Yes. When does that happen? Well, that happens at 0, pi, 2 pi, dot, dot, dot. How do we write that? That theta can't equal k pi. Anytime, any multiple of pi would cause us to divide by 0. So again, when we prove first, then we could check everywhere in our proof, where are we dividing by 0? And we had to solve all of those places that we're dividing by 0. Part B, again, rewrite out the question and draw the line. Again, we'll start with our main strategy. Our main strategy is to change everything to sine and cos, and we can change secant to 1 over cos. And when we have fractions inside of fractions, we wrote this down before, but maybe we'll write it down. If you have fractions inside of a fraction, what do we need to do? Get a single fraction in both the numerator Get a single fraction in both our numerator and denominator first. This is a super important strategy and one that students like to skip and creates all sorts of mistakes when they skip. So, how do I do this? Well, first of all, I hope that you see that the top, since those are both over 1, we could technically write that as a single fraction. It's all over 1. Then on the bottom, I would need to multiply, because right now this is 1 over 1. I don't have a common denominator there. How do I add fractions? I would need to multiply this by cos theta and this by cos theta. And if you multiply top and bottom by cos of theta, you're multiplying by 1, which is about the only thing you're allowed to multiply by in an identity, because it doesn't change the value. It just changes what it looks like. So then on the bottom, I now have a common denominator of cos theta, and if I add the tops, I would have cos of theta plus 1. So now we have a single fraction in our numerator and a single fraction in our denominator. That's important because once you have, oh look at that, I've got it written down already. Once you have a fraction over a fraction, you can flip the second one and multiply. And these factors are identical. And if you're multiplying and factors are identical, they can simplify. And we just get cos theta. Which, check our other side, back to, it is the same. So I can write my statement. And we're done. Our proof. Now, I'm going to just zoom so we can see the whole proof. I'm going to take out my highlighter. And I'm going to look at all the places I am dividing. So, for our non-permissible values, cos of theta can't equal 0. And cos of theta plus 1 can't equal 0. We have two different places on the bottoms of those fractions. One of them is just cos theta, and one of them was cos of theta plus 1. So do you remember how to write your zeros of cos of theta? Right? We had an odd number times pi over 2. Could write it that way. And this one, if you move over, that's like solving when cos of theta can't equal negative 1. So theta also can't equal k pi. Actually, that's not quite right. Let me erase it. Theta can't equal pi, because that's where pi is equal to -1. 2 pi is okay, and 0 is okay, so it would be pi plus 2k pi. So our non-permissible values are wherever cos of theta is equal to 0, and wherever cos of theta is equal to -1. And we have to write the general solution for that so that we list all of our non-permissible values. So questions for practice are 4, 8II, 9II, and 11.